Hello and welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery. Give us 10 minutes and we'll give you the universe.
And I'm Anna. It's great to be with you. We've got another busy show today, Avery, with stories ranging from the cosmic echoes of colliding black holes to some incredible homegrown discoveries.
Absolutely. We'll be mapping the largest structures in the universe, spying on a visitor from another star system, and checking out Europe's ambitious new plans for landing on the moon. So let's get right to it. Our first story is a mind-bender. Astronomers have found evidence of second-generation black holes.
Right, and this is a huge deal. The idea of a hierarchical merger, where black holes that are themselves the result of a previous merger then go on to merge again, has been a theory for a while. But now the LIGO Virgo Kagra collaboration seems to have found the first direct evidence.
So it's like black hole parents creating a new, bigger black hole child.
Exactly. They detected two new gravitational wave events, GW 241011 and GW 241110. Both showed some very strange features that you wouldn't expect from first-generation black holes formed from collapsing stars. Strange in what way? Well, for one event, one of the black holes was spinning incredibly fast, faster than is typically thought possible for a black hole born from a single star. A violent merger, however, could spin a black hole up to that kind of speed.
Okay, that makes sense. A cosmic collision giving it an extra push. What about the other event?
This one is even wilder. In the GW 241110 event, the larger black hole was spinning in the opposite direction to its orbit around the smaller black hole.
Wait, spinning backwards? How does that even happen?
It's the first time we've ever observed something like that. The thinking is that this kind of bizarre anti-aligned spin is a potential signature of a second-generation merger. The chaotic dynamics of a previous collision could have flipped it around. It's like finding a planet that spins in the opposite direction of its orbit around its star. It tells you something dramatic happened in its past.
Wow, so these gravitational wave detectors aren't just hearing collisions, they're starting to uncover the life stories of black holes. That's incredible.
It really is. And the implications are profound for understanding the cosmic landscape. If hierarchical mergers are common, it could be the primary mechanism for creating the supermassive black holes we see at the centers of galaxies. It's a key puzzle piece we might have just found, connecting the smallest stellar mass black holes to the largest behemoths in the universe.
So this isn't just about individual black holes, but about the grand architecture of galaxy formation itself. It changes our models for how galaxies evolve over billions of years. It's amazing how these tiny fleeting ripples in space-time can tell us so much about cosmic history.
It really is. And from the unbelievably massive, we're going to something a bit closer to home and a discovery that is just as inspiring. It involves a very young astronomer from Ontario, Canada.
I love these stories. Tell me more.
Stuart Patel, who is just 12 years old, has discovered two possible new asteroids. They've been designated 2024 RX69 and 2024 RH39.
12 years old? That's amazing. How did he do it? You need some serious equipment for that, right?
He did it through a citizen science program called the International Astronomical Search Collaboration. They provide real astronomical data to people around the world to analyze. Siddharth was poring over images from their telescopes when he spotted these two objects moving against the background stars.
That's the best part of citizen science. It opens up real research to anyone with passion and a keen eye. And clearly, Siddharth has both.
He definitely does. Apparently, he's already an award-winning astrophotographer and dreams of becoming an astronaut. Now, the discoveries are still preliminary. It could take years of follow-up observations to confirm them and officially add them to our solar system's catalog.
Still, to make a potential discovery like that at 12, he's already contributing to the field. What a future he has ahead of him. It's a great reminder that you don't need a PhD to make a difference in astronomy.
Absolutely.
All right, let's zoom back out. way out, from spotting tiny asteroids to mapping the largest objects in the entire universe. A team led by University of Chicago scientists has been cataloging galaxy clusters.
And these aren't just any objects. Galaxy clusters are the most massive gravitationally bound structures we know of. They can contain hundreds or even thousands of galaxies, all held together by an immense amount of dark matter.
Right, so by mapping where they are and how they're distributed, you're essentially mapping the invisible skeleton of the universe. The team used data from the Dark Energy Survey to do this. And the big question is, what does this map tell us about dark matter and dark energy?
Well, this is the exciting part. Their findings aligned almost perfectly with our current standard model of the universe, the Lambda CDM model. This model predicts how structures should form and grow over cosmic time, driven by the pull of dark matter and the push of dark energy.
So no new physics needed just yet? Sometimes confirming the current theory is just as important as breaking it.
Exactly. There have been some tensions in recent years between different types of cosmic measurements. Some studies hinted that the universe might be a little less clumpy than Lambda CDM predicts, but this new independent analysis of galaxy clusters shows that no, the clumpiness is just right.
That's a huge relief for cosmologists, I bet. It means the model holds up. And I see they mentioned that future telescopes like the Rubin Observatory and the Nancy Grace Roman Space Telescope will be able to take this kind of mapping to the next level.
They will. They'll survey the sky wider and deeper, giving us an even more precise map and a stricter test of our cosmic model. It's a foundational piece of work for understanding our universe's evolution.
Fantastic. Okay, from the cosmic web, let's turn our gaze to a solo traveler passing through our neighborhood. Let's get an update on a visitor from very, very far away.
You must be talking about the interstellar comet 3I Atlas. It's only the third interstellar object ever detected, and it's currently reaching its perihelion, which is its closest point to our sun.
Interstellar objects are always exciting, a real piece of another solar system, right? Here for us to study. I know there was some online hype about it. Is it living up to that?
Well, it's not an alien spaceship, if that's what you mean. The observations show it displaying very typical comet features, a fuzzy coma of gas and a dust tail, both created as the sun's heat vaporizes its ice. Scientifically, though, it's incredibly interesting.
Of course, every photon we collect from it tells us something about the chemistry of the protoplanetary disk it came from, wherever that was. Are professional observatories getting a look at?
Yes, many are. Even the European Space Agency's JUICE mission, which is on its way to Jupiter, is planning to observe it from its unique vantage point in space. But what's really cool is that amateur astronomers are getting great views too. It will be visible to backyard telescopes for the next few months as it heads back out of our solar system, never to return.
A fleeting glimpse of a traveler from the stars. It's a great opportunity for anyone with a telescope to see something truly unique.
It really is.
All right, for our final story, we're looking to the future of lunar exploration. The European Space Agency, or ESA, has just unveiled its brand new lunar lander, and it's called Argonaut.
This looks impressive. It's designed as a versatile cargo vehicle capable of delivering up to 1.6 tons to the moon's surface. That's a significant payload.
It is. It's all part of ESA's push for a sustainable and, importantly, an independent European presence on the moon. But there's one feature they're highlighting that really stands out.
Let me guess. Its ability to survive the lunar night?
You got it. That's the killer. The lunar night lasts for 2 Earth weeks and temperatures can plummet to extremes. Keeping electronics and systems from freezing solid is one of the biggest challenges of long-term lunar missions. Argonaut is being designed specifically to withstand that deep cold.
And how are they testing that? It's not like you can just stick it in a freezer.
Right. ESA is using a cutting-edge simulation facility in Germany called Luna. They can recreate the vacuum, extreme temperatures, and even the abrasive lunar dust to put the technology through its paces right here on Earth before sending it a quarter of a mile away.
And the goal isn't just to land and survive. Argonaut is designed as a versatile workhorse for the Artemis program and beyond. It could deploy complex scientific instruments, release rovers to explore permanently shadowed craters, or even deliver the foundational elements for a future lunar base. It's a key logistical step in moving from temporary visits to a sustained, long-term scientific presence.
A versatile lunar delivery truck, essentially. That really does change the game. It makes the idea of a permanent human presence on the moon feel much more tangible, much less like science fiction. This is the kind of hardware that builds a future.
That's smart engineering. It seems like the new moon rush is really heating up, and it's fantastic to see Europe making such a serious and capable contribution with landers like Argonaut. It's not just about flags and footprints anymore, it's about building sustainable infrastructure.
Couldn't agree more. It's an exciting time for lunar science. And that brings us to the end of our news roundup for today. From second-generation black holes to a 12-year-old asteroid hunter, it's been another incredible day in astronomy.
It certainly has. The universe never fails to surprise and inspire. Thanks for joining us on Astronomy Daily. Be sure to subscribe wherever you get your podcasts so you don't miss an episode.
Until next time, keep looking up. I'm Avery.
And I'm Anna. Clear skies.
Astronomy Daily.